Welcome to Friday the 9th makeup session. Snowed in, but I made it to school here just in case the brave would show up. Decided to give this recording a try, see if I can help you out here. Gonna start with just reviewing through the two-dimensional arrays, gonna get into vectors, and then gonna jump to our homework problem, the tougher one, doing some file processing, help you out with that, but I'm going to leave some tasks for you to do. If you want to be really good at the coding, try the code yourself, and don't watch this until you have tried your solution. And you can compare yours. Yours is probably going to be better than mine. So here we go. Two-dimensional arrays. Remember, when we're processing arrays, it's a two-dimensional. The row comes first in our outer loop if we're processing everything in the array. And your classical for loop, remember we don't use the for each format because we do care about what row and what column we're at when we're processing the elements. Sometimes we may want to have what goes in there be some function of the row and column. And remember that for each loop you can only read the values, you cannot change them. In this, in order to change a location in the matrix here, I have to know which row and column I'm applying the value to. This one, a pretty mundane, set everything to 10. There is no other way than processing through every element in the array. You can't just say matrix equals 10. That will not work. It will be a syntax error. So processing row 0, remember, less than the length of that row's length. Matrix.length is how many rows I have it in. This is the length of that row. This particular loop doesn't assume that row 0 has the same length as everything. So we always have our column go from 1 to that, or 0 to that row's length. If I knew it were a rectangular array, I might choose width. But this is the safest way. Do it all the time, even if you know it's a square or rectangular array. This code doesn't go any slower than saving the width of the first row. Okay, if I'm printing out the array, same process. That for loop, outer for loop, going through the rows, the inner for loop, going through the columns, and what I do with the data is set right here. So you can see that for loop processing, outer loop and inner loop is the same whether I'm going to assign a value to it or read the value and print it out. Those particular examples were processing the entire array. The inner loop was processing each row. Sometimes I don't care about the entire array, but I'm only interested in a particular row. And processing the column, I have a fixed column number, but I changed my row. That's what they mean by a particular column of array. The row changes as I go row 0, row 1, row 2 to the end, but the column I'm in, if I'm processing a column, would stay the same. Now that can be confusing, so read your problem statement very carefully. When you're working on a column, the rows are changing, but the column stays the same. When you're working on a row, the row is the same, and the column is changing. So whatever is changing is the variable that will be in the for loop. Here, same thing, reading through rows and columns of a two-dimensional array, and instead of assigning it a value or printing it, I'm taking the input from the user. So everything up till what I do with it is the same. A little different here, if I'm adding up all the elements in my array, this particular one, it looks like I am calculating a sum one row at a time. So in the outer loop, before I figure out the sum of that column, I set my sum variable to be 0. The way I will often write this code like this is I figure out what I need to do inside the inner loop. Like, okay, I'm going to be adding up everything in this column, deciding that, yeah, there's going to be a sum variable that accumulates, takes what is in there and adds to what's coming next. Oh, and now I see that, by the way, before I start this loop, I better set sum to be 0. So this is where sum has a value. Now, if you forget to put this line in, the code will come to here and say, okay, I've got a variable sum. I need to take what's in there and add it to what's in this column, in this location in the matrix array. Oh, but I don't know what sum is yet. You very likely get a runtime error because you haven't defined what's in sum. Now you might think, oh, the compiler should know that it starts out at 0. But no, you need to tell it, okay, what's in there first before I start this loop is the 0. So this little part added because I know I'm going to be adding elements or adding in mathematical summation the value of what's in a particular location. And you can see here, I am also going to, when I'm done with that row, print out the sum. So because there's only one statement in that inner loop, there is no curly brace. Now, if the curly braces help you to see the code, where the looping part is happening, go right ahead and put in curly braces. And notice here in their style of coding, they put the curly brace at the next line of the for. This is a long-standing argument of programmers where that curly brace goes. So much code that I read puts it at the right side here that I tend to do that myself. But I will not argue to the death, as some will, about where that curly bracket goes. Now remember about summing by column. The column in a particular inner loop, see how the column now is the outer loop, because for each column that I'm in, that remains fixed, while row takes all the row values from 0 to 1 less than the matrix length. That means in this inner loop, column is staying the same, and I'm adding up the elements in from different rows in that same column. So this isn't a huge deal in programming column processing. What this is a challenge to you, understanding arrays. If you want to process by the column, you should recognize that the outer loop needs to iterate through all the values of column, while the inner loop changes the rows, because this inner loop is adding up the elements going through that multiple rows, same column. So just a little practice in understanding looping by throwing this at you. Summing up the columns, you're actually probably going to do that more if you're processing like financial data from some database, where the rows will represent particular transactions, the columns may represent the month or the particular account that things are being assigned to, if you're representing your data in a 2D array. And that's part of the design. If I want to find the largest element in a row, now this will give you some ideas on the solution of a couple of those other homework problems. That whenever you're finding the maximum of something in a list, in this particular case, I can just treat matrix bracket row as a one-dimensional array. And so this loop right here is the solution to finding the largest element in a one-dimensional array. And let's walk through what we're looking at. In this case, we're looking for the largest element in the row. And because I'm saying, okay, let's assume when I start at the first element in the row, remember row bracket 0, I'll say that's the largest for now. And now let's loop through the rest of them. That's why I'm starting at column 0 to column less than the matrix's row.length. Now right away here, we're not doing any error checking. that the number of columns is greater than 1. We're right away just saying, oh, we've got to have, we're assuming we have more columns than 1. Because notice we're not saying, oh, if 1 is, or if matrix row.length is greater than 1, then I'll go through this loop. No, we're just assuming, oh, I've got a column 1. I'm going to read what's in that column. So this code is assuming I have rows longer than 2 columns, or 2 columns or longer, at least 2 columns. No error checking done. That's something that will be done in a more refined code. Okay, but just assuming we're looking for the largest element in a row, we start at now the next column and just do a simple comparison. Have we found something bigger than the first one? And if it is bigger than the first one, largest less than where I'm at in the row and column, then I will assign largest to be that value. Now, if I'm keeping track of where that is, I will also have another statement that would assign the index of that largest value, because we're often looking for the location of it as well as the value. Sometimes we only care about the location of it, and in that case, we would be saying largest index equals that column that I happen to be in as I'm looking for the largest. This is an important thing to remember. When I start a loop, if I'm looking for the largest, don't do something that you might think, oh, let's just set largest to be 0. And if anything's bigger than 0, we'll say that's the bigger one. Well, you may have a matrix array full of negative numbers. So don't pick a constant that you think might work as the logical, probably the largest until I find something bigger. Choose the largest to be the first thing in your array, and then compare everything else to that element. So then you will never fail at making sure you don't, by accident, come across an array that, oh, I wasn't expecting all negative numbers. I thought 0 would be a good thing to start with. Always use your first element in your array when you're comparing things. Largest element in each column, basically the same code, except I'm reversing the use of the row and column. This time I'm setting column as the outer loop, and the element at row 0 is now going to be my largest. As I go through the other rows at that same column position, I'm comparing, is it larger than what I have in largest already? If it is, then make largest to be what I've just found. And then at the end of that loop, or that inner loop, once that inner loop is done, I have found the largest for that column, and I'll print out a lovely little message. This is just an example showing you can pass a two-dimensional array as a parameter to another function. And in this case, what is it doing? It's going to, on each column as it goes through each row, one at a time, use this wonderful printf function, very good for formatting output, where I specify the format of the output, and then I tell it what variable goes there. So learn to use printf. There's many, many examples of using it. Back in the day, this was my only way of generating output in my C programming language, which was my first real professional programming language way back in college. This was something you got to know very well. What this means is print this out as a digit fill it with leading zeros of 7 digits, expecting the output will be a 7 digits width padded with zeros. Nice thing about this is then it comes out nicely columnized. Tabs also make your output nice and columnar. And if you're generating HTML, you can put HTML tags around whatever digits to make a nice table output. So sending the name of a variable that happens to be a two-dimensional. Remember, this means this function print matrix is expecting and will get an error unless you send it a two-dimensional array. Sometimes you'll get a compiler error. You may accidentally send it a variable that's not a two-dimensional array, and as you try to process it, at runtime, you may run into index out of bounds if you're trying to treat it as an array and it's really not an array. Most of the time the compiler will catch it and won't let you send it something that's not a two-dimensional array. Another processing, sending an array as a two-dimensional array, and let's see what we're doing here. We're calculating the sum. Again, here's the calculating the sum of each row. We could easily calculate the sum of the entire array, but this one, they're setting it back to 0 as they start each row in the outer loop. Here, we're finding the largest element of each row instead of the summation, sending matrix as the two-dimensional parameter. So basically what they've done there, they've taken that code that they were already doing it, calculating this, and they're making it a function that can be used from other routines. And something that they're doing here, very helpful in your coding, especially when you have lots of curly braces around with loops within loops, putting a comment by your ending curly brace when you make methods makes it clear when you're starting a new method where to start that. I've seen a couple of you have you accidentally started your method inside of another one because it wasn't clear where that other method ended. Put comments like this. Let's see, did they do it in the previous one? They didn't do it there, but they did add it to there. And that's going to be something that will be very helpful as you're making multiple methods. When you start your method, put that comment there, and I'll try to remember to do that as I show you the example in the homework. Now, two-dimensional arrays is not where you need to stop. You can go as many dimensions as you like. Now, what that means is up to you. 3 dimensions is fairly easy to understand when you're talking graphics and vectors and 3-dimensional characters. But as you go beyond that, it's hard to visualize, but it's still possible. And just as we added a bracket for 2-dimensional arrays, we simply add as many brackets as we need for as many dimensions. And just as with 2-dimensional arrays, all this says is car dealers is going to be a 3-dimensional array. Here is where I'm setting how many are in each dimension. Rows, columns, you could call this levels. It's up to you to choose what sometimes you call X, Y, Z, whatever this represents in your data. Could be the time, account, vehicle, time of sale. All this is your choice in your application. But notice the outer loop typically is this element in the array. It doesn't have to be though. You just better make sure that the outer loop goes to less than the dimensions of that outer loop. And rather than use 10 here, I would use less than car dealers dot length. This should be car dealers bracket I bracket dot length, and this would be car dealers bracket I bracket J bracket dot length. Then process whatever's in that row. So hard coding this is dangerous. I would not recommend this technique. This just makes it easy to understand. The 10 there is because of the 10 there. The 5 there because of length 5 in the second dimension. 7 there because of the number of levels in that third dimension. Okay, they have some different programming examples. I'm going to jump now to our homework problem, help you through that, or review what we're trying to do. Let me jump over to there. Here's what we're trying to do. We've given this data from a file. Each line has this. We're going to we made that file. Let me quick go through that. I just copied that data and go to my project that I'm in. This is my arrays. Make sure I'm in the right project here. Too many up. There I made the test data. And my source, Chapter 9 arrays. So this is the code I'm in, and I basically created those 2 lines in the code. And just to plan for the future, I'm going to make a few more students. We'll make Max. This is the student that gets the perfect score. And I'm going to paste his answers. His answers exactly matches the answer key. And I'm going to save that. And I'm going to come back here. And we're going to get ready to process this one at a time. And remember how we process this. Let's first of all just think through the steps. Break it into pieces. First thing we'll do is read data from file. Well, even before that, let's open the file. Then we'll read answer key data. And then what we're going to do, we're going to then start in a loop. I'll just remind myself, in a loop, I'm going to be read user ID or student ID, and then their answers. And now, one by one, let's see, what do I need to do? I need to, since we're dealing with arrays, we're going to fill answer array with students' answers. And then we're going to figure out their score by comparing. So we're going to loop through each answer and compare students' answer to answer key. And while we're doing that, we're calculating their score. So inside that loop, calculate score. We're going to do some kind of summation. And since I'm also wanting to maybe do some debugging and list their score, their wrong answer, I might also build, what would I call it, their feedback. I'll just make it a string. So we'll build a feedback string. Maybe we'll put like a plus when they got it right, a 0 if maybe the points. How about that? We'll say, you know, the 1 if they got it right, or sorry, the 2 if they got it right, a 0 if they left it blank, and a minus. Oh, how am I going to demonstrate -1 with one character? Maybe I'll do a X or something if they got a -1, because I don't want to have 2 characters. I want to be able to have a nice little string. We'll think about that as we do that. And then after that loop is done, we'll report results to screen. And if I think about more, maybe I'll put it in an array and then store the array. One thing I realized I forgot to do is when I read the answer key data, we will fill answer key array. Because I'm going to need that when I'm in this loop comparing what they answered to the answer key. All right, so having that in my comments, and as I get ready to write this, I'm going to go to the bottom here. If I ever write any more methods, I'm going to make sure that I know that this is end of test grader. And to make sure I don't forget, this is, I actually found the solution to this, or I had done this already. I'm going to put end of solution 1. That's my solution up there. But as we build the solution now, we're going to follow this step. Now we've already done this on Wednesday, but let's just make sure we know how to open the file. And before we go further, we will stop and test. So remember how we opened that file? We need a scanner. Might as well call it my in file. And I want to read the data file, which is called testdata.dat. So I will do in file equals new scanner. And a scanner needs a file reader. This is all from chapter 3, testdata.dat. And semicolon. Now, of course, since I haven't, if you hadn't done this already, you'll have complaints about importing things. So you'll be importing the correct code at the top. We'll just add that. Notice anytime you're trying to open a file, you need some error checking, and you'll get an error about that. Go ahead and do the surround with try catch. And just remember now, all the other things that I need to do need to go inside of here. So this catch will catch after the end. So since I know catch will come if I have an error, I'm going to cut and paste that down here. And look, I want to make sure I'm not before the end of my method there. And therefore that comment is helpful to know where I need to go. Okay, so now everything happens inside the try. That means this is successful. Now that we've read it, now that we have the scanner, now I need to read the data. So let's read the first line of data. Read first line. First thing I'm going to do is just read it into a string. So I'm going to say string and S answer key. S for this is a string, just that's my way of keeping track of that, my variable names in a methodical way, equals in file dot bothers me. You can see that before. In file dot next line. Now I'm doing a next line here because I want to read the whole line and treat that as the answer key. And because there may be some spaces before and after it, I'm going to do a dot trim. That means trim away any leading or trailing spaces. And I better get my spelling right. Next line. Okay. That's my answer key. Right now it's in a string. So I'm going to want to put that answer key into my array. So since I know each answer is going to be a letter, I might as well use a char array for my answer key array. So char bracket S answer key. Not S answer key. It's an array. A key. I'll call it my A. What am I going to call it? My A answer key. My array of answers equals. Now, how long is this array to be? Well, since I know how long that first line is, new char bracket S, the string answer key, dot length. So, I didn't take that. Put the semicolon at the right. There we go. So I am creating an answer key, ready to put some values in it. So might as well fill it in. So my first line, I'm actually doing this part now, filling the answer key array. So let's jump down after that comment. I've read the data. Now let's fill the answer key with the values that I just read into that string. So, classic for loop, for, and I do care about the index I'm at, so I'm going to use the standard int I equals 0, I is less than a answer key, that way, I plus plus. What do I put in answer key? Well, A, answer key, bracket I is going to be equal to the character of each position in the string of the answer key. So S, answer key. Now, how do I get at a particular letter in a string? I can look back at string handling. I can go online and look for references to string. I can take a guess by hitting the dot. And look at that. My first suggestion is char at. That returns a character at a particular index location. Now, the big question now is it start index at 0 or 1? And look at that. The first char value in the sequence is at index 0, the lovely, wonderful help. So that's the one I want to use. So char at, and my index in this case is the position in position I that goes from 0 to the length of my, not the, oh, I just messed up. It's the string. Actually, I could use both because right up here I've set them to be the same. But just to be safe, I want to reference the string position as I deal with my string. I could have used both, but I want to always reference the original source of the length, just out of purity of logic. Okay, now I've got a problem here. What's it? Oh, I forgot to. Length of a string is a function, and I forgot the semicolon. There we go. I forgot that length for a string is a method, where length of an array is a property. Now we're ready to go. Now we have our answer key array, a answer key, filled with characters at specific positions. All right, now, first of all, I'm going to ignore the loop part. I'm going to do this, and then we'll put it in a loop, having to do with am I at the end of the file yet. So now to read the answer. Now this is a little trickier. You have to think. Let's put a little comment here. Line example, and let's look at our data file here. The data might look like this. So I come to here. If I have a line like that, this is going to be my student ID, and this is going to be the answer. So in order for this to come out right, and you often see comments like this is the answer, and this is student ID. There may be spaces in the answer that the problems they have not given a response to. So what I do is, first of all, I read their student ID. So I declare the string student ID. I'm going to call it SID, and I read it as in file dot, instead of next line, I read the next word. Next gives me a word. I may read a word in this way. And you can experiment with this, but next lets me read that student ID without reading the entire line. Now I can read the actual answers that the student gave me, reading, I'll call it, what do I want to call it? Let's see, I had S answer key, let's call it S answers for this particular student. This was their answers that they gave. And now I'm going to read the rest of the line by going read next line, meaning read to the end of the line to get the S answers. And because there may be white space here, I'm going to do a dot trim to remove any leading or trailing white space. Just saves me a time later on of error processing. At least as I compare characters, I'm not starting with spaces. I guess what this will assume, and this may be a little problem, is if they have not answered the first question and left a blank there, this will have an error. So I'm going to put a little caveat here. What should I put? Problem. This fails if first answer is left blank. Because I'm trimming the rest of that line. If they did not answer that first question, I'm treating that as, oh, is that the space between the student ID and their answers? Now, a way around this would just be to assume that there is one space between the student ID and their answers, and not do a trim of the rest of the line. For now, we'll assume that they at least answered the first question. But that is a problem with how I'm doing it right now. And that's something you'll do as you write code. I've already written this, and as I come through it again, I'm saying, wait a minute, I see that there's a problem there. We'll ignore that problem for now. Write a comment that this may be a potential problem. Okay, now that I have the answers in the string S answers, let's fill my student's answer key, or my student's answers. I'm going to call it char array answers equals, let's see, it's going to be a new char array with how many elements? Well, the same length as the answers they gave me. Or, better yet, let's just assume we ignore anything beyond the length of my answer key. Let's just go to and make sure it has as many as we expect in the answer key. Remember, because they may have not answered questions at the end, this will also give me a little error checking later on. Make sure I'm not going to process anything more than what's in my answer key. So I'm going to do the A answer key dot length. Notice, because I'm dealing with the array now, it's a property, not a method. No parentheses needed there when it's an array. Okay, so the answer key array has the student answers array is the same length as the answer key, and now let's fill it with the values that I find in S answers. And now, because this array is determining how much processing I do, I'm going to use its length as my loop control. So for int I equals 0, I is less than A answers that length, I plus plus, I like white space there. And since I'm only doing one thing, I'm not going to go over curly brace. Now I'll do A answers bracket I equals S answers dot char at the position I. So this is assuming that I have a string at least length. What's the problem with that? Oh, why do I keep missing that semicolon? Oh, I know what's going on. I read the character at each line. Now, I'm not doing any error checking here yet. I'm assuming that the length of S answers is greater than, or is equal to, or greater than the length of my array. If for some reason I trimmed off too much, S answers will be too small, And I'll be trying to do a char at of something that's not at a position, so there's a potential for index out of bounds, again, if the first or last answer gets trimmed away. So that's something that maybe I'm going to think about whether I really want to trim. Alright, assuming that that isn't a problem, let's now do the loop of comparing the answers one at a time. Now this part here, filling the arrays, this was a little newer for you. I'm going to just get you thinking about what goes here. I'm not going to give you the whole solution because this is the part where you're going to need to do some work, but I'll get you started at least. So let's just build that loop. Well, we know we have an array answers, and let's just think about this. My array answers is holding the student's answers, and the array A answer key holds the answer key values. And one at a time, I want to compare what's in a position in the answer key to the same position in the student answers. And if they haven't answered that one correctly, with some kind of an if statement, I'm going to be comparing, and might as well put that in my comments as I come to calculate the score. So before I start my loop, I'm going to need to keep track of some score. And right now the score is integers, so let's make the score, a total score, to be equal to 0 at the start. Well, we know it's 0 at the start, but we're declaring it 0. And you know what? I'm going to be, as I deal with multiple students in a loop, I'll be having to make sure I set score to 0 as I calculate the score for each new student. But for now, let's just calculate that for 1. And maybe that's something I'll let you do is we'll calculate it for 1, and then you figure out the rest. Okay, so starting with score equals 0. Now I need to loop through that answer key. Notice I'm using answer key.length to control my loop. And now inside of there, I'm going to be doing multiple things. So let's go ahead and put a curly brace. I don't know why it gave me that strange error. Usually it gives me the automatic closing and curly brace. Okay, now we compare one at a time. If what's in my answer key, A answer key, at position I is equal, and don't forget the double equals. This is a very dangerous spot here. If you do a simple equals, you will change your answer key. Make sure the double equals in any comparison. It's a very common error. In their answers at position I. This is comparing what they've typed, what they've given as an answer, to what's in the answer key. Now what do we do? Well, if it's equal, the score gets added 2 points. Plus equal 2. Now if they're not equal, there's 2 possibilities. Have they left it blank? Or is it the wrong answer? So we have to do another comparison. Now how do we compare what they've answered? Let's see, is it a blank? A answers at position I equals single quote space is a legal comparison to a character. If you try a double quote space, it will complain. It says, no, I can't compare a string to a char. Remember, A answers is chars, an array of chars. Double quotes, no good. And you see that right away with the red lines, red squigglies. Now I'm comparing a character to a character. If it's blank, what do they get? Remember the score. If they've left it blank, they get 0, right? Let's make sure. Wrong answer -1, no answer gets 0 points. Well, you know what? If I don't do anything with the score when the answer is a blank, then let's just say, okay, if it's not blank, then I know they've given the wrong answer, and the score minus equals 1. I don't do anything exciting when it is a char. The score is 0, so I don't do anything with score. So rather than have an if else in another, just say, okay, if it's not a blank, they get a -1 and skip the rest. So this is all the logic I need for calculating the score for that particular student. But just to help me out here and do a little debugging, let's build up a string as we compare their answers. This is helpful just to make sure your code is working. So here's what I'm going to do. I'm going to declare a string. I'm going to just call it s feedback. And I'm going to set it to be an empty string to start off with. And if they get a score plus equals 2, since that is more than one thing I'm doing after that if, I'm putting that in curly braces, I'm going to add to the s feedback to the end of s feedback. I'm going to add a, let's see, if they get it right, let's go ahead and show this value for that position. Okay? Alright, and if the answer is not a space, they get a -1 score, and remember I want to just one character for that, so let's do s feedback plus equals, and let's do, how about do a minus, since it's only minus and one possibility. And now because I do want to put something else there, then I'll do an else, and this will be s feedback plus equals, and since they had no score for that point, I'll put the points for that. So I'm building up a string that I will be able to help me see, am I calculating the score correctly? And I can go back to that actual file and see if I'm getting the right answer. Now for now, I'm actually building the feedback string inside of there. I'm going to leave you to finish up the other code for calculating their score and their percentages. I'm going to print to the console the, how about this? How about the answer key? I'm going to use actually the printf. I'm going to do the answer key, followed by a new line, followed by the student's answers, followed by a new line, followed by the feedback and a new line. That's how you do printf. And now I have to give it the 3 strings that it wants to put in this format. So the first string will be s answer key. Second will be s answers. And the third will be s feedback. And why did it give me multiple parentheses there? It should be it. Now we have not run this yet. Just like I told you, I should have stopped this at this point and ran it just to verify that I could read the file. I was being bold and not doing anything, running and testing. Let's run and test and see what happens. Here we go. There we see the answer key, what the student answered, the points that they got, we see here they get a minus, and now 2 for the correct answers. See how they did not answer that when they got a 0? Now that's telling me it looks like we're calculating the right things. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20 points of those, but a minus 1 for each of those. 19, 18, 17, 16, 15, 14, 13, 12, 11. They should have scored 11 out of a possible. Well, we're going to have to know the possible points here. I think there are 20 answers total here. So the possible is 40. So 11 out of 40 would not be a very good score. But I'm leaving it up to you to calculate the percentages. At this point, you have quite a bit of help in getting you to the part about calculating the score based on the summation. So here is, I'm giving you a score, but that's just a number of points. You have to take that and calculate from number of points. What do they want? They want, in the solution, they want a percent. And you might as well, if you like, you can do a switch statement or a if else if statement to compare their percentage and calculate a grade. That is something that up to you to try, and if you're having issues with that, send me an email. I can give you some hints. I'm not going to give you the full solution. Plenty of help online. Help each other out. As long as you submit an answer, working on figuring it out on your own will make you a better programmer, but getting help from your friends is not forbidden. So give that a shot. Send me an email if you have any issues with that. I'm pretty happy here. It worked the first time. Usually there's a little typo here or there that I have to hunt through. Have a great day. See you Monday.